Hey fellas, as promised, I'll give you guys a walkthrough of my ridiculously oversized home brewery. Some may call it a nano, but I guess since we don't have a commercial license and we don't sell beer for profit, it's a home brewery. This is our logo. This is what we'll be presenting to the public should we ever reach the point where we hit commercial, which I really hope happens, but I guess we'll see how it goes. So I'm going to do my best to walk through the brew house in as organized a fashion as possible so it makes sense. Bear in mind, I'm not a pro. All of this stuff I've learned from the internet and a couple of helpful people that I made in the brewing industry, like Phil at Brew Gear and Bobby at Brewhardware and a couple other guys online. So yeah, bear with me. I'm not going to edit this. This is shot on the go just by pausing it. So here we go. So as mentioned in my other posts, this whole thing started out with a set of 3 30-gallon Brew Gear kettles purchased in late 2014, early 2015. It started off living in my garage on stainless steel tables with a tiny little pony panel to control the elements. And since then, it had a complete tear down and move out to my barn, which you're seeing here, which is sort of bordering on my ultimate man cave. TV, wood stove in the corner, Red Bull fridge, and since then it's morphed into this brew house and cooling tower, etc. So started here on the HLT. It's a Herm setup. It's been that way right from day one. Nothing wrong with the 30-gallon setup when combined with the 30-gallon MLT, but a larger boil kettle. I'll touch on that a little bit later. So 30-gallon HLT, things I find are super important are the sight glass, which is on the inner side of the brew house, meaning you can see it from wherever you're standing. If it was over here on the left side, it'd be difficult to see your level when you're working kind of from the midline of the brew house. This top port here is used as a return for recirculation. It's also used for a return when we're keg cleaning and doing clean-in-place things with the bright tank and fermenters. This port here was originally meant for a thermometer, but that's now kind of gone by the wayside since this thing came into my life, our life. So now these upper ports are all used as outflow ports for the keg cleaner and clean in place. So you get 1-inch lines on there for plenty of flow. Down low here, there's a dip tube to reach right to the bottom of the HLT, fed by a 3/4-inch line down to the manifold that feeds the water pump. Teed into here, into the sight glass, is the temperature probe that runs into the electronic control panel. Something that I added that I find super helpful is I got a 6-inch tri-clamp port to add things like minerals to the water. Very, very helpful instead of constantly trying to do this while you brew, because inevitably you get a huge blast of steam in the face, and as some of you or most of you probably know, that hurts. So step over here to the MLT. This thing's kind of Frankensteined itself over the last 2 years. Again, it's a Herm setup linked in with the HLT. This very sexy 6 or 8 inch stainless ring was added about 6 weeks ago, when I realized that with the bigger grain bills that we use with the 50-gallon boil kettle, to make a really big beer, 7, 8, 9%. The grain bill is too big to fit into this standard 30-gallon kettle. So piece of stainless, a roller, some TIG welding, and a bunch of silicone later, and voila, there you have it. So again, return port up here, which originally was used for sparge and Vorlaw for Herm's return, but now is used only for return for keg cleaning and clean in place. Again here, same port as before, which was originally for the thermometer, which is now reserved just as an outflow for cleaning. And then below is the outlet for either Herm circulation or for transfer to the boil kettle after the mash is done. I'll go over all this contraption later. Also on the MLT, actually, you know what, we'll cover this whole contraption a little bit later. So move over to the boil kettle. So in the summer of 2016, one of my brewing buddies said to himself, your mash water plus your sparge water in a 30-gallon mash tun is more than 30 gallons. So we could actually be doing larger batches than what we were doing previously. So I grabbed this 50-gallon stainless Brewtech kettle, which I must say is of very good quality. Brewtech, I think they're a great job. They're very innovative, and their quality control is tight. Their customer service is very good. So this kettle arrived with, I think, 3 weldless holes, and within 4 days of it being here, it had, I think I added 7 1.5-inch tri-clamp ports. I didn't do this myself. I have a buddy who's a professional stainless welder, so for delicate stuff like this, I get him to do it. I'll do the bulkier stuff myself, but I haven't quite developed the nerve to take my TIG torch to a $700 kettle. Maybe one day. So the ports that I have here on the kettle are these 2 at the front, which serve dual purpose, one being for the sight glass, again in a good position that it's easy to see, and then also the thermal well, or the temperature probe attachment, which again goes to the control panel. Over here, this is a return port, which when transferring from the MLT to the boil kettle, that's where the wort goes in. It's also set up that if I wanted to try whirlpooling, which I have tried and I think I'm done with it, it works well for that. It's set up as a somewhat of a tangential inlet when used with a 90-degree dip tube on the inside. Around back, there's 2 inlets for the heating elements. One's a wee bit higher than the other so that the elements don't crash into each other inside the kettle. And then port above here, which is used for cleaning. And again, this is the drain port with the dip tube for transferring out the wort and for recirculation if you want to do a bit of a mix while you're boiling. It's Friday night, so what the hell, I'm enjoying a honey kolsch that was brewed in early December. It's pretty tasty. Yep, it's pretty tasty. So when I was designing all this in late 2014, and I honestly had no bloody idea what I was doing, I sat down with a pen and paper and I drew out manifolds and this and that, and I guess you got to learn some way. So this is what I've ended up with so far, and this has seen so many different iterations, it's not even funny. Some have been made during the middle of brew days, some have been made in midweek after realizing, oh, this is redundant, or oh crap, would this ever be easier if we did this, etc., etc. So I've broken it down into 3 circuits. One is the water circuit, one is the Herm circuit, and one is the wort circuit. So each circuit has an input manifold, so you can select where flow is coming from, followed by an output manifold, which is on the other end of the pump. This is a 3-pump system. Originally, it was a 2-pump system. However, I found that that was a bit limiting, because using the same pump for both the Herm circuit and for the wort circuit made it so that you couldn't do 2 things at the same time, which would make the brew day a little bit longer. Well, actually, sometimes quite a bit longer. So here on the water circuit, this is the input, which comes from the on-demand heater. So that supplies water to the entire system. This manifold here, you can see it takes a big feeder from the HLT down and into this manifold here. I've also got air there for blowing things out at the end of the day. Feeds down, that's a Chugger Max pump, which has a priming valve or dumping valve, because that also will just get spit out into the wastewater. And then from there, it gets fed up to the output, I guess what you'd call the output manifold. And the options that are currently built into the output manifold are recirculation back to the top of the HLT, which goes up there. So that's for mixing minerals and making sure that there isn't any heat gradients in the HLT. The second outlet goes up to the grist hydrator, which I'll touch on here in a bit. And then the third outlet goes over to this 3-way valve, which gives me 3 options. 1 is nothing. 2 is jumping water past the MLT over to the boil kettle. So that works well if you have to fill the boil kettle for some reason, or for cleaning at the end of the day, etc. And then the last option is a Herms flush circuit. So at the end of the day, you get the wort that's left out of the Herms coil, so it doesn't get moldy and yucky. I think I'm going to take a sip after every manifold explanation. So, you can come over here to this manifold, which I guess sort of is a combination of wort and Herms. So what I've done here is I used a 1.5-inch tri-clamp sight glass to do a couple of rolls. One is to see the wort, so we can get a gauge of color and when it's getting dark, when it's getting light, for runoff and etc. The other thing it acts as is kind of a small grant, a sort of something that if we know that's full, the pump is being primed, and it gives us that reassurance that we've got good flow. So this manifold that I built here can go one of 2 ways. During the mash, during the Herms recirculation, when you flip the 3-way valve this way, that feeds wort over to our left, down to that pump there, and I call that the Herms pump. Again, we've got priming valve and dump valve, but the business end of it is it runs up through here, and then it runs to this Blickman G2 valve, which allows me to quite carefully throttle the Herms flow. And the reason why I want that, and you're probably asking yourself, what the hell are you doing spending $85 on a valve, is that the outflow in the Herms system from the Herms pump dictates how much suction is being applied under the grain bed, under the false bottom in the mash tun. So originally it was based on this piece of tubing, which came from McMaster Carr and cost about $4. So if the water level is above the false bottom line, that means that there's no suction underneath and it's just flowing freely by gravity. And if it's drawn down, that means that you're sucking from underneath the grain bed, and you could be producing a stuck mash, which is no fun. Recently, like in the last week, I've added this gauge from Glacier Tanks. Did I need it? Nope. I was just mostly looking for another project and kind of like the numerical readout in terms of negative pressure. So from there, the Herms circuit runs through the valve, which I call it the Herms throttle, runs up. This is the input to the Herms coil. Herms coil goes whoop, 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 whoop. That's the sound it makes inside, and back up and out through here. Here's a little miniature sight glass. These things are a real beauty. They come from Bobby at Brew Hardware, and they're super helpful. I think they're maybe $30 a piece, but knowing that you have fluid flowing through when you're not quite sure, this is super helpful. And then from there, the Herms line runs up into this monstrosity, which again I'll get into a little bit later. But you can see where the Herms coil runs, which you can call it Herms, you can call it Vorloff, whatever. So coming back down here, when it comes to runoff time, to switch to transfer to the boil kettle, this ball valve gets thrown over in this direction, which then activates this manometer to give me an indication of negative pressure or lack thereof. Feeds itself over into, I guess you'd call this the wort input manifold, which then runs down to the wort pump. The wort pump also has a priming valve, and then it runs up to the wort output. Excuse me. Oh, I forgot to have a drink. Hold on. Okay, good. The world is right again. So that's the wort output manifold, and there's only two places the wort can go from here. One is via this Blickman valve up and into the boil kettle. So if you're filling the boil kettle, I use this, call it the wort throttle if you want to call it that, and that I can dial in to make sure that I don't produce a negative suction or negative pressure under the grain bed on this bad boy. Why haven't I added a glacier gauge to that yet? I don't know. I'll get to it. So the other possibility for output from the wort manifold is to go out to the chiller, which is right there. I also added a tri-clamp, 1.5 tri-clamp sight glass there, which also acts as a grant to view the wort, but also to ensure that the pump stays primed, and that the exit from there is a 3/4 tri-clamp to barbed fitting to make sure that pump is fed a healthy dose of wort. So I'll go through the chilling tower now, because chilling is something that we all do. Well, I think we do. The towers, well, actually, this whole frame, this stand was, it's called Jeremy Teaches Himself a TIG Weld, which I did in February of 16. Probably about 40 hours of welding. I don't regret it at all. Being able to TIG stainless is a pretty cool skill. I'm not saying I'm great at it, but a hell of a lot better than I was this time a year ago. So that's just 2-inch square tubing. The cooling tower is built out of the same material, 2-inch square tubing, just a cross at the bottom with some wheels to make it mobile, and I don't know, 7-foot stem up to the top. So the cooling tower gets fed by this 1/2-inch silicone line. I put a valve there to break airlocks, but also for cleaning and draining at the end of the day. That upper sight glass is, to be honest, probably just pure voyeurism. I really like to see the wort at the end of the day and see how it's coming out. This is a 3-inch trub strainer from Brew Hardware, which is actually pretty helpful. It holds back a lot of the trub material, a lot of the hot material, and I think it's $100 or $120 well spent. Farther down from there, I've got a butterfly valve to isolate the trub strainer in case we need to break it apart and clean it during the day. In between runs, a mitt full of hot wort isn't fun for anybody. Then we've got another sight glass just so we can keep an eye on how much flow is coming out of the trub strainer, so we know whether or not we've got good flow and whether or not it needs a cleaning. From there, the wort makes its way into these two more beer counterflow chillers that are run in how do I word this? The wort portion of it is run in series. The cooling water portion of it is run in parallel. So hot wort goes in the top of the first one, and cooled wort comes out the bottom of the second one. However, the cooling water gets a recharge between coil 1 and coil 2 because it's cold going in here, it's hot leaving here, it's cold again going in here, and hot leaving here. From there, we've got a manual thermometer run with yet another Blickman valve because that gives us that real precise control of the temperature, and that has worked beautifully. We can lock in 55, 58, 62 and literally walk away, and that temperature will not budge the entire time. My control panel came with a knockout probe, so that was integrated in there as well, which it's kind of fun to watch on the screen but not entirely necessary. After the wort's done through the chiller, that is an oxygenation assembly. I think it came from more beer. At the end of the day, it's a sight glass with a T and oxygenation stone or diffusion stone. And everything from there on is tri-clamp to make sure that to keep things as sanitary as possible. I know some of you are looking at this and thinking, holy shit, it's pretty, not exactly spot shiny, but this is not a commercial brewery and this is my barn. So sometimes it's shiny, sometimes it looks like this. So the next thing that I came up with probably a year ago was, I call it the sparge lid. It's sort of my version of all the different ways to use a sparge arm or Herm's return arm, you name it. So what I've done is I had a lid cut. I have a friend who has a water jet table. I don't get the work done for free, but I get a discount. So he cut me this nice circle with this lid cut across. I got a piece of stainless piano hinge from McMaster Car and tagged her on. Learned a tough lesson about what heat does to metal when you don't do it in steps, but I guess I'll know better for next time. These flip up lids I think are crucial. Every kettle should have them on a small setup. You know, it's good for adding things, it's good for looking in, so you don't again have to constantly be trying to do this during the day. The whole idea of the sparge lid, it basically is a great big shower head, and the way it's rigged up, I don't have it completely set up right now, but here it is. So this baby lives underneath there, and those butterfly nuts holding on underneath. The Herm's return and the sparge water, I need a camera person here, gets distributed all throughout here, and you can see that there's dozens, if not hundreds, of tiny little water jetted holes. Some of them have been drilled out to get a little bit better flow, so that the Herm's flow and the sparge water gets distributed across the grain bed as much as possible. Now you're probably asking yourself, well, what in the hell's that hole in the middle? Well, let me tell you. So about 6 months ago, I was bored and wanted another TIG welding project. So I decided that this home brewery needs a grist hydrator, which I know is totally absurd, but it gave me something to do and work on my TIG skills, and that's kind of what I contribute to the brewery. I like the tech, I like the techniques, and the machinery. I mean, I like beer too, don't get me wrong, but I like playing with stuff. So I ordered a bunch of parts from Glacier Tanks. I got their 4-inch tri-clamp grist hydrator, along with the this is a grain funnel that comes with it, which has a 4-inch tri-clamp. This is a 4-inch butterfly valve, which we use to meter the grain into the grist hydrator. Connects here again with a 4-inch tri-clamp. This was a 4 by 6-inch spool, and that's where that hole in the sparge lid plays in. At the beginning of the brew, when we're putting in the grain gets 5-gallon pailed up into that custom-made hopper, and you can see the mirror that lets us keep an eye on things. And we meter it down. I know that when this grist hydrator water valve is wide open and this butterfly clamp is open 2 clicks, grain enters the MLT at a rate of, I need to check my whiteboard, 0.33 pounds per second. So I know what the grain bill is, I know how much water is going in, and we time it that way. Again, I know that a grist hydrator is complete overkill for a home brewery, but it was fun. And also, that setup right there, I can completely adapt to our 10-barrel system, which hopefully one day will be a reality. Other things that we've done, when we moved out to the barn here, we needed a vent hood. So I'm very grateful that one of the guys in our brewing group works at a fabrication shop where there's a metal brake. So we were able to fabricate up that vent hood for above the boil kettle. Got some 8-inch ducting there with a $180 Vortex fan, which does a decent job of getting the steam outside. On the other side of this wall is a lean-to, so that sort of made my venting options a bit restrictive. I'd do that better next time. Enough said. So this bad boy here, made for us by Ryan at Electric Brewing, Hebrew Supply. Custom job. It's bigger than what he offers off the shelf. This is a 100 amp total unit. It drives 4 5500 or 6000 watt elements. It's not PID control. It's controlled by BCS 462 by a BCS 462 unit, which gives us temperature inputs from the HLT, the MLT, the boil kettle, and from the chilling tower, the knockout circuit. It also puts power out to the 3 different pumps. I do not let the computer control the pumps at all for fear of running one dry or pushing something to a kettle that it doesn't belong. So this thing controls the temperatures for us, but it's been a godsend. That pony panel that I spoke of, 28 minutes ago, was a huge pain in the ass, constantly flipping breakers on and off, trying to keep the temperature under control. This just does it for us. It's beautiful. The control is on any computer or mobile device that's attached to this network. One guy that we brew with knows strawberry pie stuff, so I got myself a discount 32-inch TV up on the wall, so even if we're in the back of the room grinding grain or cleaning or doing something, we can keep an eye on from a distance what our temperatures are doing and make sure nothing's gone awry. Yeah, a panel it wasn't cheap. I think it came out to $2,400 US, which translated into Canadian is like $1.5 million. I think it was 31 or 3200, but it's made life so much better. If you're going to run a professional nano brewery, 1 barrel, 2 barrel, 3 barrel, I would say it's something that you got to have, so that you can carry on with your day, whether you're washing kegs or grinding grain or doing paperwork, or it's crucial. Again, you'll notice this tower looks a lot like the cooling tower. It was built just to hold the panel in place and kind of keep it close at hand. Something I added last fall, you'll see that alert flashing light thing there. I don't know why. Within our brewing group, there's a combined level of education that's, it's 50 or 60 years of post-secondary education, yet for some bloody reason we can't stop overfilling the HLT. So I went on Amazon or eBay and bought I think it was $80. Can you see it there? There's a mechanical float valve back there. So when the water gets too high, that light starts to blink and says, "Hey dumbass, turn the water off." It's been pretty helpful. It's not perfect yet, and eventually it would be pretty cool to have it wired into the BCS, but baby steps. This here is my wall of utility / wall of shame. I have accrued a ridiculous amount of stainless steel. I'm not really that ashamed, because it's nice to have around when I think of something, when I think of an idea of what to change on the keg washer, or for the CIP or something in the brew house. I have what I need. I know there's a lot of stuff there, but especially here in Canada, getting stainless fittings up here, like it's a couple of weeks away. I know you're going to say, well, what the hell? Why don't you just put it on overnight? Well, if you've tried shipping something overnight from the U.S. to Canada, and then you'll know what the brokerage fees are to get that done. 5 half-inch teas that cost $15 can quite quickly cost $200 in overnight and brokerage fees. Yeah. That is a Rinnai RSI 75 on-demand boiler. You can get them on eBay or Amazon for about 1,200 Canadian, so probably 900 American. And that thing has made our life infinitely better. The water, when it hits the HLT, is basically at mash-in temp. It might need 5 or 10 minutes of heating up before we're ready to roll, but this thing saves us 2-3 hours every brew day. I can't imagine running a pro nano brewery without some sort of on-demand heater. So that is, as you probably recognize, a basic home RO system. The water out here on my acreage is really, really hard. Like, if we were gonna use it, we could basically make stout and some more stout and some more stout, and that would be about it. So softened water runs from the house out here to the barn through the RO system, and then up onto that 275 gallon tank on the mezzanine. The float switch shuts it down at about 180 gallons, because we'd have to go on a pretty crazy brew fest to use more than 180 gallons in a week or in a couple of days. So that is a tank full of reverse osmosis water, and then what we do is use one of the online calculators. I think it's Mr. Malty or Mr. Brew Friend or something. Tells us how many grams of calcium carbonate and calcium sulfate and everything else to add to make the water as if we were brewing in Vienna or Edinburgh or Denver or Jameson, Saskatchewan. So there's a walkthrough of the brew house. That lasted a lot longer than I thought. Sorry about that. If you guys have questions, PM me, email me. Happy to help, happy to share ideas, listen to your ideas. Maybe I've completely gone astray. Wouldn't be the first time in my life. Maybe later I'll do a video similar to this. I'll show you the manual keg washer I built. Fermentation vessels. I mean, they're conicals. A bright tank. I've got a glycol power pack going to be built here in the next couple of months. Yeah, thanks for watching. Cheers.